Okay, hello and welcome to everyone in Year 8 or anyone else that's decided to have a little look at this. Here is a sample space diagrams lesson. This should be your lesson 3 of the week, Year 8, and it's all about sample space diagrams, which I imagine a few of you haven't heard of yet, so hopefully you'll learn a little bit about that today. This is a video lesson, so there'll be opportunities for you to pause the video, have a go at something yourself, and then go through the answers with me. So let's start. So, two fair six-sided dice are rolled and their numbers added together. Complete the table, also known as a sample space diagram, to show all possible scores. So here we have a sample space diagram. We've got the options you can have on dice 1, 1, 2, 3, 4, 5, 6. Options for dice 2, 1, 2, 3, 4, 5, 6. Now, the idea of this is you use the information you've got to create all the possible outcomes. Now, this is key because a lot of people think that they're always added together. Now, they are added together in this case, but it could be looking at the difference. It could be looking at them multiplying together, or a product, they might say, which means multiply together. This could have said the sum or the total, which is just another way of saying add them together. But I'm going to write in this bit here a little add, because obviously we might get into a habit of thinking these are times, like a times table, almost looks like a old school times table grid, doesn't it? But it is add. We should be adding all these numbers together. So, for example, if I rolled a 1 on my first dice and a 1 on my second dice, if I added those two together, I'd get 2. If I rolled a 2 and a 1, I'd get 3. A 3 and a 1, a 4 and a 1, a 5 and a 1, a 6 and a 1. So that gives you all the different options, just if I got a 1 on the second dice, but different things on the first die. I could, of course, get a 1 on the first dice and a 2 on the second dice. Now, you might be thinking, well, we've already done a 2 and a 1 and got 3. 1 and a 2 and got 3. But, of course, because you could get a 2 on one dice and a 1 on the other, or vice versa, that means it actually there's two different ways of getting that. So that will increase the probability of that happening. Okay, and in fact, the probability of getting a 3 is double the probability of getting a 2. You can only get 1 2, but you can get 2 3s. And I'll go on to that in a bit. So, you might eventually, I mean, you can just add. You can just pretend this is like an add times table sort of thing and just add them all. But you might see there's a bit of a pattern here. Obviously, best to quickly check that your pattern is correct, but look at that, diagonals. And there is our sample space diagram. So just to be clear, that is a sample space diagram. Don't forget that. That's what it is. Right. Now we're going to use our sample space diagram to work out the probability of certain things happening. So I've just spoken about the probability of a 3 happening. We have got a 3 there and a 3 there. Now, we've also got a 3 here and a 3 here, but that's just 3 on dice 1 and 3 on dice 2. That's not an outcome. Outcomes are conveniently here in red. Okay, that's after I've added the 2 dice together. Okay, I don't know if you've noticed as well, but what's the probability of getting a 1? I don't know if you've noticed, but there's no 1s at all. And of course, even though there's a 1 on the dice, the lowest you can get on dice 1 is 1. The lowest you can get on dice 2 is 1. So the lowest score you can get by adding them together is 2. Okay, so that's a bit of a common misconception, so just bear that in mind. So what's the probability of getting a 3? Well, there's 2 3s. So 2 out of, and now we're going to have to work out how many different options there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Boop. Okay, obviously I don't need to count them all through. I've got 6 here, 6 columns, and 6 rows, 6, 12, 18, 24, 30, 36 different options. And of course, 2 out of 36, both in the 2s, 1/18. Okay, I'll give you that if you did that, but you don't always, so be careful. Probability 4 or more. Let's grab a different pen for this. So probability 4 or more. We've got, these are all 4 or more. It's not more than 4. It's 4, the number 4, or more than that. 4 or more. Starting to think I probably just should have said, okay, well, there's 3 that aren't in this and taken it away, but I'm committed now. Okay, so we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 15, 21, 27, 33 over 36. And they're both in the 3, so divide by that, we get 11 over 12. Next one, 5 or 8. 1, 2, 3, 4 of them. Right, in bracket 4. 8, 1, 2, 3, 4, 5 of them. So that's 5. So there are 9 in total. Okay, quarter. And the very last one, probability of not getting a 12. Well, the chance of getting a 12, there's just one there, is 1 out of 36. That's probability of getting a 12. So the probability of not getting 12 is the rest. 35 out of 36. Let's make sure that's clear. That's not the same thing there as the one above. Okay, 35 out of 36. Right, question for yourself. There it is. Pause it. Have a go. Unpause it. And then I'll go through the answers. Right, hopefully you've had an opportunity there. So, 2 fair 6-sided dice, same question. Okay, I rolled, and the difference. Okay, so not the same question, the difference between them recorded. Now, that does mean you're subtracting, but difference basically means you're always doing the biggest take the smallest, because difference of 5 and 2 wouldn't be -3, whereas 2 minus 5, of course, would be -3. So difference just means biggest take smallest. If they're both the same size, it doesn't matter. So, 1 take 1, 0. 2 take 1, 3 take 1, and so on. 1 take 2, of course, no. 2 take 1, so 2 take 2, 3 take 2, 4 take 2. It's getting a little bit more complicated now, but I think you'll see a pattern if you haven't already soon. I mean, hopefully you can work out, of course, all the ones that are the same have a difference of 0. Either side of that 0, they're only 1 apart. Further still, 2 apart. And further still, 3 apart. And then 4. And finally 5. Okay, so that is our sample space diagram. I won't write it again, it says it there. Okay, that's the sample space diagram. Find the probability of a 3, getting a 3 this time. So, we should do that one in green. We've got 1, 2, 3, 4, 5, 6. You could check, but there's 6, 12, 18, 24, 30, 36 there. Simplify that. 1 over 6. Probability of 0. Let's do that in red. 1, 2, 3, 4, 5, 6. That might in the exam, so it's the same as that one. In the exam, it might say something like, what's the probability that you get the same number, or something like that. Obviously, it means the same probability of a difference of 0. 2 or more. Whew. I'm going to do that in black. 1, 2, 3, 4, 5, 6, 7. Of course, we've already used 3s. We can use it again. 8, 9, 10. Let me check that. 4, 7, 9, 10. But of course, there's the other side, 2 or more. Now, you might be able to work out, well, hang on, that's going to be the same again, but otherwise, 4, 7, 9, 10. So there's 20 of those, and 20 over 36 simplifies to 10 over 18. But of course, that simplifies. That's in the 2s as well. And you could have gone straight to that 5/9. And probability finally of not 1, well, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. That means that there are 26 that are not, and they're both in the 2s. You can't go any further than that. Right, next opportunity for a pause, and this is the last question as well. So there's your question. Question 2. Pause it. Unpause it. So when you're ready, and I'm going to assume you've had enough time there. Let's go. Right, so a bit different. We've got different numbers now. Not just a normal fair dice. We've got 2 fair spinners, so it's fair. It's got an equal chance to get all of those 4. Equal chance to get those. So that means that because they're equal chance, we can set up, you know, this is going to be absolutely fine. Each of these final things will have an equal chance. Their scores are multiplied together. That's key. And if it's not, I mean, often now they'll highlight that in the exam, like make it bold. But why not get you know, put a pen around it, make it really clear that's reminding you, and then why not get it there as well, just so it's really, really helping you out, so you don't forget. So this is multiplying, so 2 times 1. So just quickly, in case they haven't filled this bit out for you, 1, 2, 3, 5, 1, 2, 3, 5, 2, 3, 4, 2, 3, 4. That's where those things are coming from. Multiply them out, 2, 4, 6, and 10. Okay, you might think, hang on, 2, 4, 6, 8, but of course that's 5, not 4. 1, 3, 3, 2 3s, 6, 3 3s, 9, 5 3s, 15, 1 4, 2 4, 3 4s, 5 4s. Okay. Probability of getting a 2. Well, there's only one of them, so 1 out of, not 36 this time. 1, 2, 3, 4, 8, 12, 1 12th. Probability of getting an odd. Let's go with green. Odd, odd, odd. Yep, that's it. All the others are even. Multiples of 2. Right, so there are 3 out of 12, which is the same as a quarter. Now, the next one, I'm going to do in red because I don't need to circle all the evens because, of course, being odd is the same as not... Sorry, being even is the same as not being odd. Sorry, they're opposite. You know, you can't get anything else. You can't get odd, even, and something else. It's odd or it's even for these numbers. They're all whole numbers. They're either odd or they're even. So probability of not odd, or if 1 quarter is the chance of being odd, 3 quarters. Okay, if you got 9 twelfths and then simplified, same answer. And then finally, a probability of more than 10. I'll do that in black. 1, 2, 3. Do we include the 10? No, it's more than 10, not 10 or more. So is 10 more than 10? No, it's not. So we don't include that one. We've just got 1, 2, 3. And that's also 3 out of 12. So that is 1 quarter simplified. Okay. Any questions at all? Anything you're not sure about? Anything on the homework sheets or anything you're not sure? Please do just put a comment on the show my homework and ask for help. And then I'll try my best to make sure that I help you out and get you to solve whatever problem you have. All right? Thanks a lot and see you later. Well done.